Finally, we've made it to arrays. Arrays are really going to open up our ability to handle and manipulate data in a much more sophisticated way. So we use variables, right, to store values, but there are limitations to variables. So there's a variable problem. So one of the problems with variables is that they only store single values. So take a look at this example. Say you needed to collect 100 scores, right, for your students. So you can already maybe get a light bulb there, right? A loop seems pretty obvious here. But unfortunately, you can't, work the counter into a variable declaration. You can't say int score and then, throw an I in there and somehow magically Java is going to rename your variable, right, to a combination of score and I. You can definitely print out strings like that, but you can't name variables dynamically like that. Uh, Technically, there are ways, right? If you get really advanced, I think it's called reflection in Java, where you can generate variable names like that, but that's super, super advanced. Um, Typically, not recommended to do. But yeah, let's just focus on what we have at hand, right? Is that variables, they don't work that great when you need to declare many of them. Perhaps, right, in this example, 100 of them. This would take a long time, would definitely not follow our principles of right, not repeating yourself. That would look terrible as a programmer. So again, we could use a loop, right? But we would have to reassign the same variable over and over. Again, you can't cake in the value of I into the variable name. That's not possible. So you could recycle in score, right, and reassign it over and over. That is possible with a loop. And with some clever coding, you could calculate the average, the highest, the lowest. I'll definitely show y'all some examples in some videos outside of the lecture slide videos. But yeah, you could do it theoretically. This could work, but then you wouldn't be able to reuse the scores in the rest of your code. Maybe you needed to check the average later on in the code, in at the end of your code, or maybe you wanted to print them out over and over again outside the loop. Every time you reassign score in this loop, the previous score disappears because you took its place in memory, right? You replaced one score with another, and so the other one just gets collected into the trash. So yeah, there has to be a better way to do this, right? If you do want to collect multiple values, store them in a single place in a single variable, there has to be an alternative. There is an alternative, and it works great with loops. So if you do want to collect all the scores, save them somewhere, group them together, point them at a single variable, your answer is going to be, of course, right? We're in the array section, so it'll be with arrays. Before we get to that, I do want to notice there's no star on this slide. It's not required knowledge. I won't test you on it. But just to give you an idea of how this works and why it works. So consider this variable declaration in score is equal to 90. So the variable score holds a single value, 90, right? The integer 90. So the computer assigns a memory location for score to store the single value. It doesn't need that much space. In fact, because it's an integer, we know it takes up 32 bits. So that's way back when we were talking data types and variables in Java. That was, I think, our second lesson. So yeah, it doesn't need much space. So it makes enough space to hold that one value in memory. But when you declare another variable, let's say int score 2, uh, that next variable could be stored in a completely different place in memory. So it's not going to store it in order. It's just going to store it wherever it finds first, right? The first open spot. And the way that it does find this memory, it's not always going to do it in order. We call this non-contiguous, meaning that the variables aren't stored in a specific order. They're not in a row with each other. Let's look at a little image right here, right? So we have non-contiguous. So score 1 might be stored here. Score 2 might be stored here. Maybe we have a variable called input might be stored here. And then another one called output will be here. So it's kind of just all over the place. That's how variables are stored in memory. Luckily, we have an alternative, and that's arrays. So an array is a data structure that allows you to store multiple values of the same type in a single variable. We call these values elements in the array. So what is a data structure? An array is a data structure. Well, we got to define that too. So it's a way of organizing and storing data so that it can be accessed and manipulated efficiently. If you plan on becoming a full-fledged programmer, a professional programmer, the next step, one of the most important steps in your uh, computer science education, is actually your data structures class. So it turns out array is one of many different types of data structures, but it's definitely arguably the most important one. So we learn it first because it does kind of provide some fundamentals, right, for all the other ones that you learn for the other data structures. So yeah, an array is a data structure. A data structure is just a way of organizing data. Why are arrays special? Or what makes them special? How do they organize data in a special way? Well, because you can store multiple values. And it turns out that they're able to do this because they store the memory in a single contiguous block of memory. So this is how arrays would store things. So if you wanted to store two scores, it would look like this in memory. If you wanted to store three names, it would look like this in memory. If you wanted to store, I don't know, two Boolean values, right? You want to group them together. There you go. This is how arrays look. They are contiguous. They put the values right next to each other. And that's going to make it easier for us to work with the data, access it, manipulate it, change it, etc. So let's go back to arrays for a sec. So the key idea is that the memory is continuous. The values are stored next to each other. Think of them like houses on a street, right? So these are houses, they're neighbors, right? We organize the neighbors based on the data type, right? They all have the same type of variable. As long as you know the address, you can access specific values in the array. As long as you know the address of a house, then you can, locate the house. And that's really easy to do, right? When those houses are your neighbors. It's not hard to figure out what the next address is. If I give you your address is 801, then naturally the next house might be 802, right? Really might be 803, right? The way that most even and odd numberings work. But yeah, you can guess the next address pretty easily. Well, that's exactly how arrays will store data. They can calculate the next location of the next element, and that's why we're able to group them together. We're able to access them together. We're able to use them together because we group them in memory. So yeah, use arrays to store many values or elements, and you can point them to a single variable. So arrays are stored in a row or contiguously. But why? Because the computer knows the type of each element, so it knows the size of each element. So in the example of integer, right, it's 32 bits. So using this math, you can actually calculate where the next location will be. So if we go back here, if we know that this block of memory is 32 bits, then I know where the next block is going to be by using this formula. It says starting address plus index times size. So the next index is going to be at the 64th bit, right? That's where it's going to start. It's going to end at the 64th bit. It's going to start at the 33rd bit and end at the 64th bit. Because each block, right, is taking the same amount. So here we're at 32, here we're at 64, here we're at 0, for example. And then, this block would start at 33. So yeah, not required knowledge. I'm not going to test you on this. But it is going to make more sense when you get to data structures. They'll bring this up a little bit more, contiguous and non-contiguous. I can tell you in my data structures class, we barely even talked about this. So you're definitely getting some really valuable knowledge here with how these structures work. But just know that the core message of this is that arrays, they store the data right next to each other. Variables don't do that. And the advantage of storing them next to each other is going to be really fast to access those values, change those values, etc.